All right. Hello and welcome, everyone. This is PubNub's first webinar on the challenges of securing the Internet of Things. My name is Rohini Kandi, and you can find me on Twitter at RohiniP. We also have Jasdeep on the webinar, and his Twitter handle is scalable with a 3 instead of an E. All right, so let's start with a bit of background on Jasdeep and myself, and then I'll introduce PubNub to those of you who haven't heard of us before. So Jasdeep, I think you're on mute, but would you like to start us off? Is Jasdeep there? All right, Jasdeep.
There we go.
Okay,
Okay.
cool.
So every time I unmuted, I was being remuted because we both clicked at the same time. So yeah, I've been a developer. I'm Jasdeep Jaitla. I'm a solution architect here at PubNub, and I've been a developer for about 20 years. And I'll be handling all the Q&A during Rohini's presentation. And I'd love to hear all the questions that you have regarding anything with IoT and security and our access manager. And I'm looking forward to hearing your questions.
Awesome. All right, and my name again is Rohini, and I'm the product manager at PubNub. I've been managing very technical products for several years now, worked with engineering-centric companies and building products for developers. And for the most part, building applications and hardware for the Internet of Things is not much different than other development work. But as I started attending more IoT conferences, talking to industry and thought leaders in this area, I noticed a couple interesting points of discussion. And the first was this concept of the internet part of IoT. So as often described, there are many machine-to-machine communications within the category of IoT. You might have smart appliances, home appliances, to wearables that may or may not be plugged into medical diagnostics, to connected cars and transportation. And these, along with a lot of other categories, are the things in IoT. But when we're describing the internet part, most presentations simply had some sort of amorphous cloud that connected everything magically, something similar to the slide here. And so the point is that everyone seems to be talking about the big data and the devices that make up IoT, but not the lines to the cloud that connect them all, which brings me to what PubNub does. PubNub is the global network for secure, high-speed, and reliable data streams for any device anywhere in the world. Through our high-performing network, we can send and receive data from sensors, mobile devices, embedded chips, or software applications anywhere around the globe in a quarter of a second. The second fascinating topic at many of these types of IoT events is around securing the internet and things. And that's really the subject of this presentation. So obviously, IoT developers need to focus on IoT security when building or developing their products. But unlike established industries that have common tech stacks or design patterns, the IoT world is pretty different. For instance, a developer that builds financial trading apps in large banks can draw upon like 20 plus years of experience in the security nuances for that specific vertical. But IoT is still in its early stages. So at PubNub, there are a few design patterns that we use, and I'll talk about in this session, but these topics aren't really unique to us alone. But before I start going into the top 10 challenges of securing IoT communications, let me start by showing you this clip from 60 Minutes. Leslie Stahl, the reporter on this clip, visited DARPA, the Defense Advanced Research Projects Agency, and got a pretty cool demo of a drone while she was there. So let me just play that.
So he's in complete control.
He's in complete control, that's right. This is the normal configuration that if you bought it off the web and you brought it home and started playing it, this is how it would work. So are you ready, Pat?
Yeah.
So what's Pat going to do?
So Pat is playing the role of the malicious hacker. He's going to connect to the quadcopter and tell the quadcopter to stop listening to Dylan. So Dylan won't be able to do anything anymore with the quadcopter. Pat will have complete control. So you want to tell us when you've gone ahead and taken over?
I'll do it right now.
Okay.
I've lost control.
So Pat's in complete control.
So now are you in
And
control,
Dylan's
Pat?
lost control.
Yeah, so Dylan no longer has control. Pat, can you make it go up in the air?
Oh my goodness.
Can you make it like wiggle back and forth so it says hi? Yeah, so it's like jiggling. And then can you make it land? Oh, whoa!
Oh, you killed the drone. So you did that.
Yes. I didn't mean to do it that quickly.
Yeah, well, that if you were an enemy and it was a real drone, you might do exactly that.
Right. So the devices were constructed to be easy to connect to. So they weren't constructed with security in mind at all. So it's not at all hard to hack into and take over control of such a copter because there's no provisions for security.
Really, the main part is the quote that I really kind of wanted to make sure that you all heard was that security wasn't really a thought that people had when building and designing this drone. It was kind of something that was put into effect later. It wasn't built with that in mind from the start. And I'm going to try one more clip to see if it works, but because you may or may not have seen a lot of drones out in the wild, but I'm sure you've seen or heard about the buzz in the connected car space. So cars with sensors or computers built in to help drivers monitor their driving, navigate, or even allow cars to drive themselves. So let's see if you can see this clip. Otherwise, I will also send out a link to this as well.
This is a regular new car. The masking tape is only there because we agreed to obscure its make and model.
We'll give them the illusion they control the car for now.
Kaufman has been working on this for 5 years with multiple research teams.
You want to hit the fluids?
Oh my gosh.
There we go.
There we go.
What's that? What's that? What's that?
That's the windshield wiper fluid.
No, wait, so this is something that a hacker had.
That's right, a hacker. Like obviously you didn't turn on the windshield wipers.
Using a laptop, the hacker dialed the car's emergency communication system and transmitted a series of tones that flooded it with data. As the car's computer tried sorting it out, the hacker inserted an attack that reprogrammed the software, gaining total remote control. Oh my God.
The horn.
They're doing that?
They're doing the horn.
With these clips, it's really just showing the security issues that are very concerning. At the end of the clip, Leslie Stahl loses control of her brakes in the car. And in a 2013 DARPA study, that it demonstrated the ability for them to connect to a vehicle's computer system, send commands, and ultimately control engines, brakes, steering, and other really critical vehicle components. Modify the speedometer, gas gauge, or anything like that. So as I said in these reports, these devices weren't designed or provisioned with security at the top of mind. But I think we can all agree that things like this, be it drones or wearables or sensors or vehicles, they need to have that consideration from the very beginning. So let's start with the topic you're all here for today. All right, well, a la, I guess, David Letterman style, we've created our own top 10 list of the top challenges in securing the Internet of Things. I'll go through each one in further detail, but here's a summary at a glance. First, we need to talk about the same language in order to ensure that we're defining the concepts in the same way. And, sorry, I'm just going to move my screen. As we know, unprotected devices on the Internet will be attacked. Encryption is needed throughout the entire data lifecycle, not just from point to point, but from end to end. And a single security model for IoT communications is necessary, so we're not all rebuilding the same wheel. Similarly, data stream access controls allow you to make more fine-grained permissions access, tracking device metadata so that you can encrypt certain parts of the content of the message, but allow for metadata that can be used for any sort of logic processing. Secure provisioning and firmware updates for devices that are already out in the field is something that is a pretty big challenge for a lot of device manufacturers. Compliance with the always changing global regulations that are out there, and leaving security up to each project team so that each one has to start from scratch and building it all up. Again, similar to the case of like the financial vertical, there's going to be different nuances there than there are in other industries. All right, so first things first. To secure the IoT, we must first understand and define the concepts so we're all speaking the same language. Once we can explain the security challenges in the same way, then we can work on the solutions. So the Internet of Things are devices that send data, receive data, or do both over the Internet. But there are different ways that data can flow to and from IoT devices. So there's the one way from the device, or two-way or bidirectionally. Next, there are different speeds at which data flows through the system, in a continuous flow, all in real time, or in spouts, in spurts. And of course, there's the unicast or broadcast of data as it happens. So private one-to-one communications, one-to-many broadcasts, many-to-many, or signaling that occurs many-to-one. Sorry. An example to many-to-one would be having a multitude of sensors on the field and relaying their status to a single server that aggregates and analyzes, for example. All right, so now that we've defined how data flows through the IoT implementations, let's create a vocabulary for the pieces of that flow. So a few straightforward definitions to begin. First, publishing and subscribing is simply the sending or receiving of data to and from devices. The idea of presence, next, is to detect whether a given device is actually online or offline. Next, the message is really the core content of the data in a given format. For instance, key value pairs of information. And then you can think of a channel as kind of like this abstract pipe through which a message is delivered or received. And you can create as many connecting pipes that carry messages. In this example, what we're calling data streams, channels are being used as topics. So we have a sports topic, finance, politics channel. And the use case here might be, a news aggregator application that has these categories available to its end customers. So anyways, I think we can hopefully agree on these 6 core concepts. And using these terms and language, we can then talk about security and communications within IoT. So security means a lot of things, and there are a lot of topics that need to be considered in order to protect devices that are online. Things from data access permissions to legislation unique to different countries around the world, to encryption and protecting personally identifiable information data. I think the sign says it all in the middle when it says good luck. But we can do something. We recommend taking the challenges of security off the client device and putting it onto the network where it can be centrally controlled. Already there's too many manufacturers that worry about getting their IoT product to market quickly, and they care more about getting it to market quickly than about securing it. And in some cases, the devices are so small that it's hard to build in that correct protection. So offloading that security to the network is the right answer for many developers. And at PubNub, we call this the data stream network, which may sound completely foreign, but we've been progressing towards that over the last 25 years. So first we had, internet backbones, and they provided peering services, routing, POPs. They spoke TCP, UDP, and then that became so commonplace that people simply just stated, I need an ISP. Next, on top of that, we had, the content caching and delivery. And folks like Akamai offered additional services and spoke other protocols. And then that just turned into, I need a CDN. And so in IoT, we need another layer, a DSN, a data stream network, that provides all of this functionality and speaks all of these other different protocols. With a data stream network, we can offload security from the device to that network. The third challenge with IoT security is with encryption. So TLS alone doesn't cut it anymore because it's a point-to-point encryption, not an end-to-end encryption. And with IoT developments, this doesn't work because data has to go through a lot of points in the chain, the network, the caching layer, the storage layer, analytics, maybe even a triggering layer. And on top of all of that, these layers could be from different vendors with completely different security provisions. So instead, AES offers end-to-end security. With AES, you can strongly encrypt the entire message all the way through because only devices with the encryption keys can decrypt the encrypted data as it's sent or received. But a lot of chip companies already have AES support, and a lot of chip companies have AES support already built in. But sometimes you want to introspect the message along the way. For instance, with the triggering or analytics layers I mentioned before. So you'll have the content encrypted, but you want to be able to parse something about that message so that you can trigger other actions. Topic. So the trick in order to parse out the right content is to split the message into the body and an envelope. So you can encrypt the contents or the body itself so that no one can read or act on it through the pipe. But then you can put the actionable data in an envelope so it can be used. The envelope data could be things like tags, for instance, and then the body and envelope are both wrapped to protect it even further using TLS. This gives different security levels to the data that's streamed between devices. So those with TLS rights can access data on the outside of the envelope, and those with the AES encryption keys can access data inside the envelope. Oh, I'm sorry. I guess I missed the animation there. All right, so we want that kind of device control, but we don't want the device to be listening on a port, because then hackers can create malware infections, steal data, create denial of service attacks, or really execute any arbitrary code on the device. So that seems like an uphill battle though, right? I mean, security is currently a $70 billion industry in the US with the corporate firewalls, intrusion detection software, and prevention systems. But even those don't always work. There are so many devices and server breaches in the news recently, and the cost of all of those breaches are exorbitant. So how do we do real-time device control for the home, the car, etc., if we can't listen on the open internet? Well, let's go back to the original premise that we want to prevent all open inbound ports at all costs. Devices should then only make outbound connections. That way the door is closed to accessing the applications and services behind those open ports. The connection outward can be left open, and then the device can listen in with a secure tunnel back from the network. But the problem is, on the internet, we can't just assume that that'll work because connections fail all the time, like when you're going through a tunnel or losing cell signal, or even moving from 3G to 4G to Wi-Fi, things like that. So the next step people often try is polling. But polling really doesn't scale. It causes additional battery drain, network bandwidth requirements, and things like that you have to keep in mind. Instead, you really need a global data stream network that can deal with the catch-ups, different protocol requirements, and security requirements. And with this data stream network, you can speak MQTT or CoAP or WebSockets, and security can be handled by that network using that same publish subscribe paradigm I mentioned. All right, so now we're on, I guess, topic number 5. I just want to make sure I take a quick break here to see if there were any questions from Jasdeep. Did you see anything that we need to, I guess, take an intermission for?
Yeah, we've actually had a few interesting questions. So one of them was, are there different encryption methods available besides AES with PubNub? And yes, so we provide the AES 256-bit encryption libraries in our SDKs for convenience. But since you're sending a string through PubNub, JSON, HTML, those are all really just text strings. So you can encrypt it using any method that you want prior to sending it through PubNub. So you have full flexibility over the encryption methods that you use. And there was another question that's actually related to this is, how are the AES cipher keys deployed to the devices, and will it be the same for all the devices? So what PubNub provides is what's called an authorization model, not an authentication. So we don't store usernames and passwords in our system, and we also don't store any of the cipher keys. So it's through your own authentication mechanism that you would be delivering the cipher keys. So your devices are going to be authenticating with your backend system, and at that time you can give in return for successful authentication the cipher key for that device, or the cipher key that they should use in the type of communication they're doing, and any of the devices that are associated with that communication. So there's a lot of different use cases. And so that's when you would be delivering the cipher keys. We don't store them because we don't want to store them. We don't want to actually have all the information that could decode any of the encrypted messages. That way, if we are subpoenaed by a three-letter organization, we don't really have any way of handing over the data. So those are two interesting questions that actually come up all the time, while I'm helping customers, is the encryption methods and how to deliver cipher keys.
That's awesome. Yeah, those were perfect questions. I'm glad we got to hit that topic in a little bit more detail. Fantastic. All right, thank you, Jasdeep. And we'll also have some time at the end for more questions, so keep them coming. All right, so next, the next topic is, so by using the same message channel paradigm once again, we can offload the requirements for defining access controls now to the network. So by using tokens, you can create fine-grained control over, for instance, which tokens are provided, a read token or a write token, which devices receive those tokens, and even which data streams those tokens grant or revoke access to. In this example, it's the quote-unquote A channel. And so this is a one-to-one design for tokens. And these tokens have the additional benefit of defining expiration or timeout limits and revoking any access at any time. So in other words, the network becomes the traffic cop that handles the authorization Jasdeep just mentioned for a bidirectional communication flow to and from the devices. And when we first started this discussion, we defined presence, which was one of the core components to the vocabulary we would be using in this presentation. So by taking our last example one step further, let's say you have a node or server that's authorized to capture the heartbeat of a device or set of devices. So that perimeter node can then send out a notification stream that tells other sensors or a central server whether your devices are online or offline. Then with that authorization, you can also send other heartbeat messages, like the power remaining on the device or a health check of the device hardware. And any changes to status or the device state can then trigger actions or alerts as necessary. This powers the real-time device state to ensure security of the hardware and software. In other words, the network is really handling that device monitoring. So,
you're choppy.
Oh,
we need to plug you in. You only have one.
I'm just learning that we have some technical difficulties, so I can plug in.
Just keep going.
Okay, all right. I apologize if there's any choppiness on the video for everyone watching. I'm not really sure what's going on, but we're trying to fix it. All right, so let's get into the next two sections because I think these are something that a lot of folks ask us about. So these cover the design patterns we recommend for device provisioning and firmware updates. So let's say, for instance, a customer buys a home automation kit and tries to set it up in their home network, but the firewall blocks the connection which enables remote access. So usually using that same publish subscribe paradigm, let me see if I can get the, all right, great. First, a new device or client subscribes to a designated tracker channel and announces itself to the provisioning server. This client has some secret or private channel info that's available in its PubNub present state setting. So then next, the server sees that join event with the accompanying secret channel info in that present state, and the server is the only one that has read access to that announced presence channel. So only the server can see this because only the server has that read access to the client device's presence channel. But the third step is that both the client and server now disconnect from the announced channel and resubscribe on the private channel communicated in the previous step. The server then performs whatever back office provisioning tasks it needs to, returns the production runtime configuration settings to the client, and then disconnects from that private secret channel. And then finally, the server returns to listening only on that announced channel that it started listening on, and the client device, meanwhile, disconnects from the secret channel and resubscribes on its newly assigned runtime channel with its newly assigned configurations. And that at a very high level is device provisioning with a data stream network. Similarly, firmware updates are a big consideration for IoT deployments because many IoT devices that are really already on the field and almost rarely replaced. So if new security vulnerabilities are found on those devices and they need to be automatically updated and patched right away, this is a way to do that. So with firmware updates, the server first lets its devices know that a new firmware update is available by broadcasting an alert message on a channel that all of its devices can read to. Then the devices that are online, and we know which ones are online through presence, they download that update immediately. And for those devices that aren't online, they can actually download the update from a cache on the channel when they're booted back up and available. All right, we're at topic number 9, almost there. So the next big challenge in IoT security are all of the potentially disparate global regulations currently in place. I mean, not only that, but there are also vertical specific rules and regulations like HIPAA, for example. These regulations are constantly evolving, and we just need to be prepared for the new requirements and legislation as they happen. Most of these standards really try to regulate where data is physically routed or transferred. So Safe Harbor is an example of that type of requirement where it requires data to only be within data centers within certain EU countries. And using a data network, you can actually route your data streams to those appropriate geographic regions or not allow your data to go through specific countries or regions. And the final point in this presentation is that offloading IoT security to each individual project team doesn't always work. We've seen examples of breaches that have happened in the last few years. And these were just a few of them that we kind of found and picked out. But even more recently, just over the last few months alone, we've had Sony Studios being hacked, the U.S. military's Central Command's Twitter and YouTube accounts, and Anthem's huge security breach that happened in January. Even in a recent government study about connected car technology from this year, it was found that security and encryption measures varied widely from manufacturer to manufacturer, and almost none of those manufactured devices were designed to limit the transfer of certain data or personally identifiable information. Additionally, no standards were in place for the appropriate retention time of data from vehicles. So as potentially a response to this, a vehicle-to-vehicle regulatory proposal from the U.S. Department of Transportation was recently made available, and that outlined the communication capability for new cars. So we do need those types of standards to help each team reach a starting point, but those standards are really just not enough. It's quite unrealistic to expect hardened security from each IoT project team if those individual teams have to design, build, and test from scratch. What we really need is specialized security systems, but we shouldn't have to reinvent the wheel every time a new refrigerator or television is created. We need a system that's flexible and strong enough to shield a broad range of devices and communication gateways. And that's why we need a global data stream network for the IoT. And that's where PubNub fits in. All right, so that was kind of at a very high level, the top 10 security considerations that we at PubNub see quite often and what we talk through our customers with. But I think we would love to keep this as interactive as possible and hear about your questions, your use cases, and talk through those some more. Jasdeep, are there any other questions that you wouldn't mind sharing?
Yeah. Yes, there are. So one of them was, can I send streaming data like video from a webcam through PubNub? So video streaming is a very specialized form of streaming. And so PubNub isn't quite suitable for that, and we have a lot of different technologies that are much more sort of specialized or suited for video streaming. And one of the use cases that actually comes up quite a bit that our customers use with PubNub is WebRTC. Since it's becoming more and more popular, and hopefully Apple will support it one of these days with Safari and iOS. But a lot of applications are using WebRTC for video streaming. And so the key part, and one of the more difficult parts of implementing a WebRTC solution is the signaling part. So getting the other end to ring, getting their phone to ring, basically indicating that there is a call, coming in. And our customers use PubNub for that because we can maintain a connection to PubNub at all times, and so you can signal that there's a phone call, or a web video call. So the signaling part is where people use PubNub, while the actual video streaming is through WebRTC itself once the connection is made. So PubNub is still very essential for that use case, and we have a lot of customers actually that use WebRTC with PubNub. So not particularly for the actual streaming of the video part, and it's not actually needed because it can, at least with WebRTC, it's point to point. So what happens if you suspect an auth key is compromised? So you're using our access manager and you think an auth key is compromised. You can, in our system, you can dynamically revoke that auth key and all the rules associated with it. So the devices that are using the device or devices that are using that auth key will no longer have access to the channels and services, whether it's publish or subscribe within PubNub, using that auth key. So you can revoke it at any time. So each auth uses its own AES key. Do I need different AES key for each edge node? That's an interesting question. The reason I bring things up right after my previous answer is that it's really actually in your control. So an auth key is something that's freeform in our system, meaning that you can use any type of string to be your auth key. You can use a UUID, for instance, or you can associate it with an LDAP key, or it's freeform, so it's flexible. You don't necessarily have to have your AES key associated with the auth key. They're actually quite separate. You wouldn't necessarily want to name your auth key the actual AES cipher key, because you're actually revealing what the cipher key is in the auth key. Even though it's secure, meaning it doesn't get transmitted, it's not visible because we're using TLS encryption, you still probably would want to name it something else, your auth key and your AES keys. So they are kind of separate concepts. The auth key is basically, it's like an OAuth token, meaning it's associated with a set of permissions. And you're basically creating that auth key in our system and associating permissions with it through our API. Do you have a solution for auth key hacking when using PubNub in a web app? So if you suspect that, this is related to what I just answered actually. If you suspect that a user's auth key has been compromised, then you can revoke all the permissions on the auth key. There's no way to prevent. There's one type of hacking that is almost impossible to prevent, and it's identity hacking. So if someone actually knows all the passwords to my banking, because they've hacked my computer, did key logging or any type of thing that allows them to actually know the passwords on my account, there's no way for me to prevent it. There's no way for the bank to prevent that person from logging in, which is why we need to use really good passwords and be smart about the things we click on, etc. So there's no way to actually deal with that. So if an auth key, if someone is able to hijack a computer and be able to get passwords and get the auth key, then there's no way to know that they've gotten the auth key, right, or the passwords. And the same is true for my bank account. Other than that, if you suspect an auth key as being compromised, or if a customer reports that that their computer has been compromised, just like a credit card, you can revoke all the permissions. You can disable the credit card. You can revoke all the permissions associated with that auth key. Well, now the questions are just flooding in. Let's see if I can keep up. Is there a limit set on auth key generation in the PubNub system? No, there is no limit. So you can have one for every user. You can have several for every user. Different auth keys can give permissions to the same channel. So one channel, and you have 1,000 auth keys, for 1,000 users, all giving access to the same channel. So there's no limits here in any way. What encryption libraries do you recommend for IoT devices? This is actually an interesting question. It really depends, and you're saying, which are usually very limited in computation power and memory, right? So this really the answer completely depends on the device and its capabilities. If it can support, the AES encryption, that's a great standard encryption form. But you have full control. So I guess the answer is it depends. The lovely answer, it depends. So it depends on the device, and if it's so underpowered that it can't do any form of encryption, that's an interesting scenario where you would want to at least secure the channels through the access manager. And it depends on how, I guess, how sensitive that data will be. There's other ways of architecting that type of system where you have the devices actually connect to a local hub, and that hub has a little bit more computing power and can do all the encryption before it goes through the internet. So that's another way of dealing with that. Let's see. There's a lot of questions that just came up. Why only symmetric key encryption and not asymmetric key encryption? Well, you're in full control of the encryption. So we just provided the AES 256-bit in our SDKs for convenience because it's often used. But there's no limit. There's no restriction as far as the encryption because you're encrypting the data prior to sending it through PubNub. So you're publishing it through PubNub in its encrypted form. So you have full control over that encryption. So you don't necessarily you're not limited to AES 256-bit or our library. You're in full control. So there's a lot of flexibility there. Let's see. I think we got to most of them. Let's see. Let me read this one. This one's a little bit long. Give me 1 second. So if we don't provide, so basically the question is kind of long, but it's why don't we, if we don't provide authentication services, then how do I go about, do I still have to develop authentication services on my own to deploy AES keys and et cetera? And yes, so we're not in the business of providing authentication mechanisms like social login companies like Janrain, for instance, allow you to do social login from basically every social platform there is, so Twitter, Facebook, etc. So they're a social login service, single sign-on social login service, and that's their primary business. Our primary business is actually providing, secure network data streaming, through PubNub, right? So it's really the communication layer that allows you to have bidirectional communication with devices, remain connected at all times, using very little power, and be able to stream data in real time. So that's our primary objective, and what we focus on is doing that better and better and at higher scale and much cheaper than doing it yourself, right? So that's our primary business. It's not authentication. However, we use our access manager to be able to associate permissions and rules within our system, within the channels, for publishing and subscribing, and seeing presence information on devices, etc., being able to secure that in our system. So authentication is something that our customers do on their own, and every company has different ways of doing their authentication based on their business model, etc. And so we can't really be in that kind of business to be able to provide every possible variety of authentication you might want. So yes, you would still have to build your own authentication system and keep all your users and devices, IDs and passwords, etc. yourself, but then use our access managers to control access within PubNub for all the networking and streaming communication between those devices and your servers, or between devices to device. So I think that's about it for now as far as our time. Oh, is one more question. Is there a limit, size limit for the message that go through our system? We have a 32K limit per message. And if you have to go, a 32K is actually quite large when you think of it in terms of JSON. So that's the size limit per message. And if you have content that actually exceeds 32K, you can obviously break it up into multiple messages and add metadata for the number of parts to those messages, so it can be reassembled on the other side. But 32K is quite large when it comes down to actual practical use.
Fantastic.
So I think
Were there
what's that?
questions?
I believe so.
Fantastic. Thank you, Jasdeep. I'm really glad we got to get a little bit deeper with everyone's specifics. If any of you have more questions, you can always reach out to us at any time. I just wanted to kind of wrap up as well. We'll be sending out a short survey to all attendees at the end of the webinar. All the participants will be entered into a drawing to win this OzoBot, which is like this cool, tiny little programmable robot that comes with some accessories and game activities. It's a perfect little widget to keep on your desk at work when you're looking for a break. So please help us and fill out that survey. We'll also be sending out a recording of this webinar, and we're actually working on a new IoT security white paper, which is in development right now, and as soon as that is ready to go, we'll send that to the attendees as well. I wanted to apologize once again for some of the choppiness that you all experienced, but hopefully the recording is a little bit smoother and cleaner, so we'll get that to you as soon as possible. So stay tuned for more goodies to be delivered to your inbox from PubNub. I want to thank you all for your time, and we hope you enjoy the webinar. Thank you.